So let's look at some examples of solving for theta, okay? So when it comes to solving for theta, like if I give you something like sine of theta is equal to square root of 3 over 2. So to show work on this, you can sure plug into a calculator, but to just show work, gosh, you guys in the chats. Okay, so we asked ourselves, when is sine positive, okay? When is it positive? So all students take calculus. So we have it positive in quadrants 1 and quadrant 2, right? Everyone is positive, sine, cosine, and tangent are all positive. Here is sine is positive, but cosine and tangent are both negative. We just draw two triangles, that's it. One thing we also know is that the sine is the opposite and hypotenuse. So looking at this triangle here on the right, the opposite is over here on the right side because it's opposite of the angle, and hypotenuse is 2. And we've seen this triangle a lot. It's a 1, 2 square root of 3 triangle. For the one on the left, it's still angle, opposite is square root of 3, which is positive, and 2 is hypotenuse, and the adjacent is 1, but negative. How did I know it was 1? Because we've seen these triangles. This was a special 30, 60, 90 triangle. If you're not sure, and you're like, how am I supposed to make sure? You can do Pythagorean Theorem if you want. Square root of 3 squared plus b squared equals to 2 squared, which is 3 plus b squared equals to 4, minus 3 to both sides. B squared is equal to 1. Well, b is 1. Now, one of the things when you take a square root here, if I take a square root, b is equal to plus and minus square root of 1. So we actually end up with plus and minus 1 here, which we end up with the positive and the negative version. So we had more than one possibility for there. So going back here, what type of angle goes in a 1, 2 square root of 3 triangle? We said next to the 1, it has to be 60 degrees. 60 degrees in both. So theta could be 60 degrees. That's the easy one, right? That's from 0. But the harder one, to get to quadrant 2, starting from 0, count it 90 over 90. What's 30 degrees left at 180? So 60 degrees left at 180. That's going to be 120. We can try counting in radians. 60 degrees is the same as pi over 6 for us. Okay, same as pi over 6. So in radians, this could be pi over 6. And right here, we're 1 short, 5 out of 6. 5 pi out of 6. So for the work for the test, you guys have to make sure you draw the triangles. That's how you're going to show me you know the work. If I just see the answer, I just think you're using a calculator. Okay, triangles have to be drawn in the right quadrant, correct quadrant. And one of the ways of knowing that is all students take calculus. Okay, now I'm going to do the similar question. I'm going to call the cosecant of theta is 2 over square root of 3. Or you might see this also as 2 square root of 3 over 3. And we mentioned quickly in our last class before is that if you see this funny fraction, those aren't sides that we know. But if I rewrite it as this guy back here, yeah, we do know the sides. 2 and square root of 3, those are in a 30, 60, 90 triangle. So when is cosecant positive? Well, let me give you a couple of hints. Cosecant, we said, was hypotenuse over opposite, which is really sine. Opposite over hypotenuse. It's the same thing except it's just the reciprocal version. So what I want you guys to see here is that cosecant is really just sine, and it's hypotenuse over opposite. So when we talk about reciprocals, when you just flip a fraction, it doesn't change the positive or negative aspect of it. So in what quadrant is cosecant positive? It's positive whenever sine is positive. Whenever sine is positive. So sine is positive, all students take calculus, positive in quadrant 1 and quadrant 2. Now let's label these sides. Hypotenuse is 2, got it. The hypotenuse is 2 for both of these. And the opposite is square root of 3. Opposite is square root of 3. Square root of 3, square root of 3. Oh, have we seen these triangles? Square root of 3 and 2, the third side is 1. And this side's going to be negative 1 because we want left. So for this problem, this is again, we write the 60 next to the 1, and our angle theta is 60 and 120, or dividing by, oh, darn it, I made a mistake up here. Shoot. This here is wrong. That's wrong. That's so wrong. Okay, that's super wrong. This is not pi over 6 is not right. It's pi over 3. Pi over 3. If this is pi over 3, this part's wrong. That's 2 pi over 3 because it's 1 short. Sorry, I was thinking 30 degrees. Please fix that. I made a big mistake up here. So theta, since it's 60 degrees, is pi over 3. 180 divided by 3 is 60 degrees because this is the same as me saying pi. And the next one is 2 pi over 3. Now, the problem in IXL, they will kind of spin things around. One of the problems was, for instance, 3 sine of theta is equal to 3. Okay? Well, we don't know how to solve if there's numbers in front of it. So what we do in Algebra 1, we go ahead and clean it up. We clean it up. Sine of theta is equal to 1. Now, this is a triangle that we do know. We can do this without a calculator. 1 over 1, opposite over hypotenuse, right? Invisible 1. When is sign positive in quadrants 1 and 2. How do I know that? All students take calculus. So the sides are 1 and 1. Opposite is 1. Hypotenuse is 1. Opposite is 1. Hypotenuse is 1. Remember, looking at the right triangle, ignore the left. The opposite side is this guy over here. On my left side, the opposite side is this guy over here. Have we seen a 1, 1 triangle before? It's going to be 1, 1, and the third side here is going to be 0. So where does this triangle exist? If one of the third sides is 0, that means it shrinks. It closes up. Right? So this closes this way, and this closes this way. So this angle here is actually a 90-degree angle going up right here. Think of it as a mousetrap. The mousetrap is going to close. It's going to close on it. Okay. Okay. So this is theta is standing straight up. So that's 90 degrees. In radians, that's pi over 2. So let me give you another one that looks a little more difficult. Here's one. Negative 2 cosine of theta minus 2 is equal to 0. We can't solve for cosine unless if we get it alone. Plus 2 to both sides. Negative 2 cosine theta equals to 2. Divided by negative 2, divided by negative 2. Cosine of theta is equal to negative 1. Okay, so what angles would give us cosine as negative 1? If you memorized 0, 1, negative 1, 0, 0, comma, negative 1, and 1, comma, 0, right? These are points 1 unit away. You can see, hey, when is cosine negative 1? Cosine is your x value, and that's at pi. But no, I often don't memorize that. I don't memorize it. What if it's for the SAT and I forget? So, but I know that cosine is negative in quadrants. All students take calculus. So cosine is positive in quadrants over here. So it's going to be negative everywhere else. It's going to be negative everywhere else. Cosine is negative everywhere else. So I'm going to draw it in quadrants 2 and 4. Cosine stands for adjacent over hypotenuse. You have to tell yourself what it stands for. Cosine is adjacent. Adjacent over hypotenuse. So those are the two sides. So it's going to be negative 1, hypotenuse is 1. We've seen this triangle before. 1, 1, and the third side has to be 0, 0. So if the side is 0, is this really standing up? No, it collapses down. So we're actually at pi. Theta is 180 degrees, or in radians, this could be called pi. Okay. So let's move on today. So one couple things I want to make sure you guys are okay with are what we call reciprocal identities. Reciprocal identities. Reciprocal identities. And what we're trying to say quickly in a nice fashion is that sine of theta is the same as cosecant, but as a flip version. Why is this true? Let's look at the lettering. Sine is really opposite over hypotenuse. Okay. Well, cosecant is hypotenuse over opposite. And to flip this over, we don't like fractions. We multiply by the reciprocal. 1 times O over H, because we did the reciprocal. We did a flip. And then we end up with O over H is equal to O over H. So this looks a little funny. This seems a little confusing. So let me rewrite this a different way. Cosecant theta is just 1 over sine. It's just the flip version. And when we look at the sides, cosecant is really hypotenuse over opposite. Let's look at the rest of them really quickly, and we'll use this. Cosine of theta is secant, 1 over secant theta. Secant of theta is the same as 1 over sine of, not sine, it's cosine. And tangent is 1 over cotangent, and cotangent is 1 over tangent. And this is just a funny way of saying it's the flip version. Secant is hypotenuse over adjacent, which is just the flip version of cosine. Cotangent is adjacent over opposite, which is the flip version of tangent, which is opposite over adjacent. So we're going to use this to solve some problems now. If you guys could get out a scientific calculator from your house, you can use your cell phones too, but I think it's best if you do have a scientific calculator. And you're going to look for some values for us. Now, in Algebra 1, we learned something called inverse operations. So the opposite of multiply is divide. The opposite of a square root is a square. And in geometry, you should have learned the opposite of sine is inverse sine. Opposite of cosine is inverse cosine, or cosine inverse, and then tangent inverse. So we're going to label these like this. These are arrows. They shouldn't be equal. Cosine inverse. Oh, that looks so ugly. Inverse. And tangent is tangent inverse, or inverse tan, however you want to say it. Okay, back to Algebra 1. X times 3 equals to 12. Opposite operation, you divide 3 to both sides, and it strips the 3 off it. X is 4. In Algebra 1, the square root of x equals to 2. So what we do is we square both sides, and the square root goes away, and we're left with x is 4. Okay, the opposite. Now for us, sine of theta is equal to, let's say, 1. Sine of theta is equal to 1. If I want to do this on a calculator, we have to somehow strip the sign away, so theta is alone. We want theta is equal to something, okay, some number. So the way we do that, we can't divide by sine. This is bad. Sine of theta equals to 1. We can't just divide by sine. This is bad. This is wrong. Doesn't work. Because you go sine divides out. But sine isn't a number. Imagine if you tried doing this for square root. If I said the square root of x equals to 2, oh, just divide by a square root. See, they just cancel out, right? No, all these are processes. And when we learn inverses, we learn the opposite process. So the opposite process of sine here, it's sine of theta is not sine times theta, it's sine inverse. So you would have to write it this way. To one side, if I do the inverse to one side, to be fair, I must do the inverse to the other. The 1. So just like before, what does 3 divided by 3 do? What does square root square do? These are opposite operations. And sine inverse, we say they're opposite operations. Leaves us theta is equal to sine inverse of 1. Now, if you guys have a scientific calculator, let's go and take a look at this on a scientific calculator. Where's my, here it is. So you'll see, come on commercials, go away. So here's what you're gonna do. On my cheap scientific calculator that you probably have used before, you always type the number first. And we said we wanna take the sine inverse of 1. So we type in 1 first. And then if you guys can see here, in the upper left-hand corner, right here, we have our sine inverse. But to get to it, I have to hit shift. And now we can use it. So now I can hit sine inverse. And it gave me 1.57. Now, 1.57 isn't an angle, actually. It's not a degree. It's actually, take a look in this corner. That's a radian. That's radians. And 1.57 in radians is actually 3.14 pi divided by 2. So this is what I'm going to do. I'm going to go ahead and change this into degrees. I'm going to redo the problem. So clear it. 1, undo my sine inverse, and that gives me 90 degrees. So, like what we said before, theta is 90 degrees. So our point is that we can do all these problems with our calculators, sure, but we also develop skills to do this by hand. Now again, to talk about this, how do I do this on a calculator? I want to get rid of sine, so we're going to sine inverse to both sides. Sine inverse of 1 is 90 degrees. If I draw that out, once again, we just did this, sine of theta is equal to 1. 1 is the opposite over hypotenuse. That's what sine means. Sine is positive in quadrant 1 and quadrant 2. The opposite is 1, hypotenuse is 1. That third side is a 0. Hey, that means there is no x value. We're standing straight up here. That is, theta has to be 90 degrees for this to be true. Okay, we're going to do another one of these problems. So I'm going to say the tangent, not tangent, let's do sine of theta is equal to 1/2, okay? What type of angle do you think will give me 1/2? Quadrants 1 and 2, because sine is positive. All students take calculus. Opposite is 1, hypotenuse is 2. That's going to be square root of 3. What angle do I write next to square root of 3? I write a 30-degree angle there. We have two answers. My first answer here would be 30 degrees. The second one is 30 degrees short of 180. That's 150 degrees. So theta could be 30 degrees and 150. Yeah. Okay, let me finish this part off. But if I want to do this on a calculator, let's try this on a calculator. So I need a sine inverse to both sides because I want to solve for theta, get theta by itself. I'm writing it out so you guys can all see. The sine's inverse and the sine cancel each other out. They're undoing each other. So we just have to type this on a calculator. So let's go ahead and take a look. Now, again, we've already said it could be 30 or 150. Now let's talk about the calculator. If I write 1/2, what happened here? This is so weird. So I'm going to scientific calculator. We're going to say, let's take a look. We're going to take the sine inverse of 1/2, okay? 1/2. 1 divided by 2 equals, please write equals, you always have the equals. And then we're going to sine inverse that. And that gives us the 30 degrees. It does slow stuff at the end because of it's doing a weird calculation by hand error. Okay, so theta is 30 degrees, but it doesn't give me that second angle. See, it doesn't give me the second angle. So if you want to, you can say, oh, if it's 30 degrees, that means the reference angle is 30 degrees, 30 and 30. Okay, so the first one's 30, second one is 150. Now, I want to show you guys something. I want to talk about this in radians now. The calculator isn't as pretty in radians. So if I put 1 divided by 2, and I'm going to change this to radians here. If you look in the upper right-hand corner, now it's in radians. Sine inverse in radians. 0.047, rounding up, 0.048. Theta is 0.48, not 0, just 0.48. 0.48. Okay. Now, I'm going to say, what is 0.48? We said 30 degrees is pi over 6, just to show you this. If I multiply this by 6, that'll give me back pi, just to show you. Times 6. That's going to give us, whoops, what? 0.0, 0.5. Sine, oh, darn it. Oh my gosh, I pushed the wrong one. Okay, that's wrong. See there, this is sine. Sine, see, I didn't do inverse. I thought I was still on inverse. 0.5, gosh. And then go shift, sine inverse is actually 0.52. 0.52, this is wrong. 0.52. Now if I multiply this by 6, that would make it pi. Multiply this by 6, that'll give me 3.14 that we wanted. Okay, sorry about that. Now for your other problems, you'll end up with problems that will say, for instance, tangent theta is 0.3, let's say. So you just do inverse. Theta is equal to tan inverse of 0.3. Plug that in your calculator and you're done. Make sure you're in the radians or degree mode. That's the part that's going to mess you up. Okay, that's going to mess you up. Now, the next hard part was this. If I write 1 over, sorry, I should write cosecant of theta is equal to 1.2. Now, cosecant is not in your calculator. It is not in most scientific calculators. Some of you guys have nice fancy ones. Sure, good luck. Lucky you. But for us, we're going to have to rewrite it. And in my video, I said to rewrite it, this is really 1 over sine. Okay, over 1. And all you do is flip it. sine of theta is 1 over 1.2. And then you do the inverse. Sine theta is equal to sine inverse 1 over 1.2. Let me do this again. What if you end up with the reciprocal identity? If I said secant theta is equal to 1.5, let's say, making that up. The way we write this in something that I can use is 1 over cosine theta is 1.5 over 1. Okay, we made this into a fraction of cosine. Flip it, cosine of theta is equal to 1 over 1.5. Theta is equal to cosine inverse 1 over 1.5.